The question says that a monochromatic light of wavelength 589 nanometer is incident from air on a water surface. What are the wavelength, frequency, and speed of the reflected and the refracted light? Refractive index of water is 1.33. Now we see here that a ray AO is incident on a water surface, water and air interface, and partly the ray is reflected as OB, and partly the ray is refracted as OC. We have to find out what is the wavelength of the reflected ray, what is the frequency of the reflected ray, and what is the speed of the reflected ray. And we have to find out all these three quantities for the refracted ray as well. Now we know that since in the reflection the rays will be in the same media as that of the incident media, so there will not be any change in the wavelength, frequency, or the speed. Whereas when it gets refracted in the water media, then obviously its wavelength will change and its speed will change as well. Now we know that the wavelength and the speed of the reflected light remains unchanged since it remains in the same medium, and we have not been given the frequency, so we will calculate the frequency with the formula. The frequency is equals to speed by wavelength, and that will be equal to 3 to 10 to the power 8 meter per second divided by 589 nanometer. This will give out the frequency as 5.09 into 10 to the power 14 hertz. And let's calculate the wavelength and the speed in the water. So the formula for calculating wavelength in a media, whereas the wavelength in the vacuum is given, is equals to lambda by the refractive index of that media, lambda being the wavelength of the light in either air or vacuum. So lambda dash would be equal to lambda by refractive index. Similarly, for speed as well, speed in any media is equals to speed of light in vacuum divided by the refractive index of that media. So using this formula, we will calculate the wavelength in water as 443 nanometer, whereas the speed of light in water as 2.26 into 10 to the power 8 meter per second. We know that frequency is given by the speed divided by wavelength. So if we divide with these two quantities, then the refractive index will cancel out each other, and the answer would be same, that is frequency remains unchanged in water. Frequency is the property of source and it doesn't change in any media. Thank you.